Hello, I am Lutfanisa Orni, and today we are going to present our project titled Postfix and Prefix Calculator. In today's presentation, we will explain how our calculator converts an infix expression into postfix and prefix notation, and then evaluates both expressions using the stack data structure. Let's begin with a brief introduction. Before explaining our project, let's understand why expression conversion is important. We usually write mathematical expressions in infix notation. For example, a plus b into c. This notation is simple and easy for humans to understand. However, computers cannot evaluate infix expressions directly because they must first determine operator precedence, associativity, and correctly process parentheses. To make the evaluation process easier and more efficient, infix expressions are converted into postfix or prefix notation. Our project performs these conversions automatically and then evaluates the expressions using a stack, which is one of the most suitable data structures for this purpose. The main objectives of our project are to understand how a stack is implemented using arrays, to convert infix expressions into postfix notation, to convert infix expressions into prefix notation, to evaluate both prefix and postfix expressions accurately, to correctly handle operator precedence and associativity during conversion. By completing this project, we gained practical experience with stacks and understood how expression parsing works in calculators and compiler design. Now let me explain the stack implementation used in our project. A stack is a linear data structure that follows the last in first out LIFO principle. This means the last element inserted into the stack is the first one to be removed. In our project, we implemented the stack using an array, which makes the operation simple and efficient. The stack performs four basic operations: push, that is used to insert an element onto the top of the stack; pop, that removes the top element from the stack; pick, that returns the top element without removing it; and is empty, that checks whether the stack is empty before performing operations like pop or pick. These operations are essential because during expression conversion and evaluation, operators and operands need to be stored temporarily. For example, when converting an infix expression to postfix, operators are pushed onto the stack. If an operator with higher precedence is encountered, the appropriate operators are popped from the stack and added to the output. This process ensures that the final expression follows the correct mathematical rules. So, the stack acts as temporary storage and helps our calculator convert and evaluate expressions accurately and efficiently. Now, I would like to hand over the presentation to my teammate who will explain operator handling. Thank you.
Hello, I'm Nafis Sultana Gungun. I will continue with operator handling. When converting expressions, we need to know which operator should be performed first. For this, we use operator precedence. In our program, the precedence function gives priority to operators. The exponent operator has the highest priority. Multiplication and division have medium priority, and addition and subtraction have the lowest priority. We also use the is operator function to check either a character is valid operator. So these functions help our program correctly identify and handle operators during conversion. Now let's look at infix to postfix conversion. We scan the expression from left to right. If we find an operand, we directly add it to the output. If we find an operator, we push it into a stack. Before pushing, we check the precedence of the operator at the top of the stack. If it has higher or equal precedence, we pop it and add it to the output. Parentheses are also handled using the stack. After scanning the complete expression, we pop any remaining operator from the stack. So the basic idea is operands go to the output while operators are temporarily stored in the stack. Next is infix to prefix conversion. The process is quite simple. First, we reverse the infixed expression, then we interchange the opening and closing parentheses. After that, we convert the modified expression into postfix using the same stack based process. Finally, we use the postfix result and that gives us the prefix expression. So the steps are reverse, interchange parentheses, convert to postfix and reverse again. Finally, let's talk about expression evaluation. For postfix, we scan the expression from left to right. Operands are pushed onto the stack. When we find an operator, we take the required operands, perform the operation, and put the result back. For prefix, the process is similar, but we scan from right to left. In both cases, after processing the complete expression, the value left on the stack is the final answer. So the key point to remember is postfix is evaluated left to right while prefix is evaluated right to left.
Assalamu alaikum. My name is Soeda Mehniga Shruti. Now I would like to explain about the arithmetic operation used by our prefix and postfix calculator. The calculator performs five fundamental operations: addition, subtraction, multiplication, division, and power. Addition is used to add two operands, subtraction finds the difference between two values, and multiplication produces the product of two operands. For division, our program checks whether the divisor is 0 before performing the operation. This helps prevent runtime errors and ensures safer execution. We also implemented the power operation using a loop-based approach. These operations are important because every prefix or postfix expression is evaluated using these arithmetic functions. Now let's move on to the program structure. To make the project organized and easy to maintain, we divided the program into several modules. First, we implemented the stack functions push, pop, and pick. Push inserts an element into the stack, pop removes the top element, and pick views the top element without removing it. Next, we developed the conversion functions infix to postfix and infix to prefix conversion. Their purpose is to transform a regular mathematical expression into postfix or prefix notation for efficient processing. After conversion, the program uses evaluate postfix and evaluate prefix functions to generate the final result. Finally, utility functions such as precedence and is operator help manage operator priority and identification. This modular design makes the program more efficient and easier to understand. Now I would like to present the results of our project. The project successfully converts mathematical expressions into postfix and prefix formats and generates the correct output. It supports multi-digit numbers and correctly follows operator precedence, ensuring accurate calculations. Overall, the results demonstrate that stack data structures provide an efficient and reliable solution for expression conversion and evaluation. Thank you for your attention. Now, the next slide will be explained by Tasfia.
Assalamualaikum. My name is Tasfia Rahman Lifa. Now I will talk about some real world applications of our project. Postfix and prefix expression evaluation is used in many areas of computer science. Scientific calculators use this method to quickly evaluate complex mathematical expressions. In compiler design, When source code is compiled, infix expressions are converted into postfix form so they can be evaluated efficiently. It's used broadly in expression evaluation tasks of all kinds, virtual machines, spatially stack-based ones. Use postfix form to execute instructions, and it's also used in various parsing algorithms wherever expressions need to be parsed. So this project's core idea isn't just theoretical, it's directly applied in many important areas of computer science. Next, let's look at the advantages and limitations of this approach. Advantages is postfix prefix expression allow fast evaluation since the computer doesn't need to repeatedly check operator priority. They require no parentheses, which makes processing simpler. They are easy to implement using a stack, and they are very useful in compilers and expression processing. Limitations: postfix and prefix expressions are less readable for humans compared to infix. They require stack memory to process, and error handling is need to deal with invalid output. So, while the advantages are significant, we keep these limitations in mind while designing the project. Conclusion. Finally, let's move to the conclusion of our project. Postfix and prefix expressions greatly simplify computation since there's no need to worry about operator precedence or use parentheses. A stack is the most suitable data structure for evaluating these expressions because its LIFO property fits perfectly with how expression processing works. Overall, this project demonstrates a practical applications of stacks, operators, and expression parsing, a good example of turning theory into real programming practice. That brings us to the end of our presentation on postfix and prefix calculator. Thank you for listening.
So now, instead of only explaining the project theoretically, we would like to show how it actually works. Here we have the source code of our project. We will briefly go through the main parts of the code and then run the program to demonstrate its functionality. So let's move on to the live demonstration.